Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn how to solve quadratic equations by completing the square. This is a really useful strategy for certain types of equations, and it's something that we're going to have to use when we get into graphing conic systems. So this is really important. I'm sorry, not conic systems, but conic equations. Completing the square means that we're trying to rewrite the equation in this form. Some quantity squared is equal to a number so that we can solve by using the square root property. The first step is to isolate the variable terms on one side as long as your second degree term is a plain x squared, no coefficient other than 1. So we'll isolate that x squared plus 8x by adding 20 to both sides of the equation. That gives us x squared plus 8x equals 20. Now we have to add what I call the magic number. This is a number that's going to turn the left side into a perfect square. And the way that we find that is by taking the coefficient of the variable term, which we'll call b, the plain variable term, the x term. We're going to divide that by 2, and we're going to square that number. We'll add that to both sides of the equation so nothing changes, but that's going to turn the left side into a perfect square trinomial. Here, 8 divided by 2 is 4, and 4 squared is 16. So I'm going to add 16 to both sides of the equation. X squared plus 8x plus 16 factors to be x plus 4 times x plus 4, or simply x plus 4 squared. The right side, 20 plus 16 is 36. Now we can solve by the square root property. Take the square root of the left side, the square root of x plus 4 quantity squared, equals plus or minus the square root of 36. The left side simplifies to be x plus 4. On the right-hand side, we know the square root of 36 is 6, so that is now plus or minus 6. We can subtract 4 to isolate x, and that gives us x equals negative 4 plus or minus 6. So our two solutions are negative 4 minus 6, which is negative 10, and negative 4 plus 6, which is positive 2. The solution set contains negative 10 and 2. By the way, when those are integer solutions, that means that we could have factored, or if you don't see a square root in your solution, that means that you could have solved it by factoring. And quick side note, x squared plus 8x minus 20 factors to be x plus 10 times x minus 2. And I could have basically read the solutions from that factored form. So factor first is still a great strategy, but if not, completing the square works. It works best when you have a first term that's x squared, and the coefficient of your x term is even. So when we divide by 2, we don't have to deal with any fractions. Now we're going to run into a couple of examples where it's not so ideal. We'll see how that goes. The next one is x squared minus 5x plus 19 equals 0. So the first thing I do is divide negative 5 by 2, and I'm going to square that. Negative 5 halves squared becomes positive 25 fourths. So that's the number I'm going to add to both sides. I also need to isolate those variable terms, so I'm going to subtract the 19 over and then add that magic number. X squared minus 5x equals negative 19. Add 25 fourths to both sides of the equation. Now the left side seems daunting. How do we factor x squared minus 5x plus 25 fourths? Well, I know that it's going to be x minus 5 halves squared. I use that b divided by 2 in the factoring. It's always going to be x plus b over 2 squared. And here, because b was negative, it's x minus 5 halves quantity squared. On the right-hand side, now I've got to do a little fraction arithmetic. The way I can add those two things together is if they have a common denominator. So I'm going to do this off to the side as well. Negative 19 over 1 plus 25 over 4. The common denominator is 4. So I'm going to multiply the first fraction's numerator and denominator by 4. That gives me negative 76 over 4 plus 25 over 4, which now I can add to get negative 51 over 4. Okay. Next step, take the square root of both sides. Square root of x minus 5 halves quantity squared equals plus or minus square root of negative 51 over 4. On the left-hand side, the square root of that square leaves us with just x minus 5 halves. On the right-hand side, because there's a negative number inside the square root, I know that I is going to be involved. 51 is only 3 times 17. That's the only factored form of that. So nothing's coming out of that square root. But in the denominator, I know the square root of 4 is 2. So I can write this as plus or minus I root 51 over 2, where the 2 is no longer in that square root. Finish by adding 5 halves to both sides, and we end up with x equals 5 halves plus or minus I root 51 all over 2. By the way, you could combine that into a single fraction because they both have the same denominator. So you could also write this as 5 plus or minus I root 51 all over 2. If we want to write this in a solution set, you can use either of those two. But remember, when you have plus or minus, there are two solutions. One using the positive sign, the addition side, one using the negative or subtraction sign. So one solution would be 5 halves minus I root 51 over 2, comma. The second one, 5 halves plus I root 51 over 2. So notice that in this problem, when we had that odd coefficient of the first degree term, x term, things got a little messy with the fraction. And we didn't have that issue in the first problem we did. Now the next problem is going to take it up one more notch from there. Notice what's different here. 4x squared plus 6x plus 5. The squared term has a coefficient that's not equal to 1, and we need to get rid of that first. And we can do that by dividing both sides of the equation by that coefficient. So I'm going to divide each term on both sides by 4. It's equivalent to multiplying both sides by 1/4. That gives me the equation x squared plus 6/4 simplifies to be 3 halves x. And I'm going to subtract the 5/4 over to the right-hand side. So I've got my leading coefficient as 1. I've got the two terms with variables isolated on the left side. I've got my constant term on the right side. I need to take half of b and square it. So half of 3 halves is 3/4. And when I square 3/4, I get 9 over 16. So I'm going to add 9 over 16 to both sides of the equation. The left side, I know how that's going to factor using what I mentioned in the last problem. This is going to be x plus 3/4 squared. On the right-hand side, and I'm going to do the arithmetic on the right-hand side, to combine those two fractions, I need a common denominator. The two denominators are 4 and 16. The common denominator is 16. So I'm going to multiply the first fraction by 4 in the numerator and the denominator. That gets me to negative 20 over 16 plus 9 over 16. And that equals negative 11 over 16. Now it's in that right form. We've got a square equal to a number. We can solve it by taking square roots of both sides. Square root of x plus 3/4 quantity squared equals plus or minus square root of negative 11 over 16. By the way, that plus or minus is the one step that students miss more often than anything else. You get two solutions from this. Make sure you include them. The left side is just x plus 3/4. On the right side, plus or minus. In the numerator, that negative number is going to come out as an I, but the square root of 11, we don't know. 11's prime. However, the square root of 16 we do know, and that's 4. So I can write this as plus or minus I root 11 over 4. And I can finish by subtracting over the 3/4. X equals negative 3/4 plus or minus I root 11 over 4. And again, you can combine that as a single fraction because the denominators are the same, or you can leave them separate. The solution set is negative 3/4 minus I root 11 over 4, comma, negative 3/4 plus I root 11 over 4. Now, we can see in these last two examples that this was not really ideal. There are going to be times where you have to use it, but if you're just solving a quadratic equation, try to restrict your use of completing the square to times where the leading coefficient is 1 and the first degree term, the x term, has an even coefficient. Then you can avoid all the work with those fractions. Okay. In the next video, we'll talk about another way to solve quadratic equations.